This video is going to cover some common biases that happen in screening processes when you're trying to evaluate how effective screening is. So the three biases I'm going to talk about are lead time bias, length time bias, and volunteer bias. And just some background, screening is routine searching for a disease. So there's certain cancers where people who are especially at risk go through routine screening where they look for the disease basically. In theory, we screen because it leads to earlier diagnosis and therefore earlier intervention, and in theory that should cause them to live longer. There's a few biases that you got to be aware of that can make screening look like it's having more of an effect than it really is. So the first one is lead time bias, and the basis behind this is that when you screen someone, it leads to more years of them knowing they have the disease, and this is perceived as having lived longer after their diagnosis. And just to illustrate that, I have this visual where we have a person who's screened who is being followed over these 7 years, and an unscreened person being followed over these 7 years. They both got the disease at the same time on year one. The screened person found out they had the disease in year 3 when they were screened, and the unscreened person found out in year 5. Now they both got the disease at the same time, and presumably they're at the same stage of the disease all the way through. But their perceived time until death here is different among the two people. So this person who is screened thinks that they lived from year 3 until year 7, all as survival time. So compared to this non-screened person, they think they only lived 2 years instead of 4 years after their diagnosis. So their perceived time with the disease is shorter, even though they both had the disease for the same amount of time, from year 1 to year 7. This screened person, they have a perceived longer survival time, when really screening didn't actually help, it just looked like it helped. The other type of bias is length time bias, and the basis behind this is that slow progressing cases are more likely to be captured by screening. So the visual here, it also has years 1 to 6 on this x-axis, and the y-axis here is tumor size, going from a very small tumor to a very large tumor. Let's assume that when the tumor gets this big, diagnosis becomes possible by screening. When the tumor becomes this big, symptoms start to show that would cause someone to go to the doctor, and diagnosis typically happens at the doctor. And here, mortality typically happens when the tumor gets this big. So if we have the tumor size progress of and this is when screening typically occurs, here between year 2 and 3. If we have this group of people who are all followed, who got the disease at the same time, their tumor originated at the same time, but this first person, the growth of the tumor was really fast, and they didn't live as long. They lived about 1 year, and as we're going across, these people's tumors are growing slower and slower. We can break down their time spent as a diagnosed case, this unscreened group. So these people never had a chance to take part in the screening because their tumor grew fast enough that they found it by their symptomology, leading them to go to the hospital or the doctor before they had a chance to be screened. And this person had a little bit more time. This person, they were screened before their tumor got large enough for them to have symptoms. And this other person spent a long time as a case because they had a very slow growing tumor, and they encountered this screening event long before their tumor got big enough to be diagnosed by symptomology. So if we draw a line down from each and show just to kind of illustrate like how long they spent as a case, you can see that these individuals that didn't get a chance to be screened, their time as a case was much shorter, where the longer, slow-growing tumors were more likely to be captured by screening, and yeah, their time as a case is much longer, even though they all got the disease at the same time. The last one is volunteer bias, and let's just say all of these people have the disease, but in theory, the only way they differ is that this group didn't volunteer to be screened, and this group did volunteer to be screened. To compare the effectiveness of screening in these two groups, we rely on the idea that they're exchangeable. Like we could take these people and switch them, and the outcome would be the same. That screening is causing them to live longer. But these two groups aren't as exchangeable because there's a few factors that are related to maybe the fact that this individual or these individuals went to get screened, where they might have decided to go get screened because they're more health conscious, and what comes with this is likely better diet, more exercise, and less drug and alcohol use. So although these people got screened, they're likely going to live with the disease longer because of their healthy lifestyle, and that has nothing to do with the fact that they got screened. So yeah, these are all biases you got to be aware of if you're going to evaluate how effective screening is.